Writing expressions where letters stand for numbers. So we're going to talk about expressions with variables, use those to describe situations. Today's I can, let me fix that here. I can use an expression that represents a situation to find an amount in a story. I can write an expression with a variable to represent a calculation where I do not know one of the numbers. So make sure you have today's date, your I cans, and you're ready to move on. So let's talk about what when x means 6. Real quick, do we remember what this little 2 means here? X with a 2? Yeah, it means squared. It means that you take whatever is here and you multiply it by itself. So if it was 2 squared, it'd be 2 times 2. If it was 8 squared, it'd be 8 times 8. And then that would be your product. Okay. So if x is 6 in every one of these situations, what's the answer? What's the solution to each one? Yeah, this one's easy, right? 10. What about here? Yep, 1. What about here? Yeah, it's 6 times 6, which is 36. What about this one, 1/3 x? Yeah, it'd be 6/3, which is the same as 2. See, the point of this is that, on something like this where we didn't have an equals line and have something here, we could plug any number into this. We just happen to use 6. Wouldn't it have been interesting, though, if we didn't know what the x was and we knew that x had to be the same in all of them, and they gave us this, and we were supposed to figure out what x was and prove that it worked in all of them? Could be very easily done, right? As long as we knew that one part and that it worked in every single one of these, we'd be good to go, wouldn't we? All right, let's move on. All right, let's do some lemonade sales. So let's complete this table. Sells each cup of lemonade for 50 cents. So how much is each one of these parts? Well, if you sell 12 cups, that would be, $6, right? Yep. What about 183 cups? Yeah, so you're going to take that. I can't do that one in my head very well. Now 183 times the 50 cents. And you wouldn't need the 0, but I wanted it because I can. Let's see, 41. 2 places. So that would be $91 and 50 cents. What about C number of cups? What goes in here? Yeah, if we take whatever it is, however many cups we have, and multiply it by 50 cents, or a more proper way to write this would be to go 50 cents C. That would give us however many dollars it is, because we don't know. We'd have to plug in a number to find that, but since we don't have a number, we can create the equation. What about the second part here? She collected $127.50. How many cups is that? Well, same sort of process, right? We're going to actually have to, in this case, divide out, because we're really trying to find the C in this. So we're going to end up dividing out, right? We're going to have to take, because it would really be C times 50 cents equals $127.50. So I need to divide by 50 cents to find out how many cups that is. Now I'm going to multiply out to make a whole number, which means I need to move this decimal here. Because I am not nearly capable enough to remember that place value being there. So let's see, 2, I'm sure you already have it done because I probably paused it at this point and asked you to answer it. And so I look silly because I'm not caught up to you. Well, I don't know. I just kind of wanted to end dramatically there. Looks like 255. All right, I'm going to do an insta check. Poof, I proved it, so it's 255. Okay, what about here? Elena is 59 inches tall. Some other people are taller than Elena. So we've got Andre, who's 4 inches taller. So how tall is he? Yeah, 63 inches, right? What about Lynn? Yeah, that one's 55, or no, I'm sorry, 65.5 inches. You're just adding here. What about here? Yeah, we don't know how many inches Noah is taller, but we do know that we have to take that 59 and add D to it. Remember that when you're talking about these with a variable, if there's no sign, that means to multiply. Otherwise, you have to write the sign. All right, I don't want to get too long here, so we're going to go ahead and build some expressions. All right, so Claire is 5 years older than her cousin. How old would Claire be if her cousin is 10 years old? Well, for this, what's going to be the basic thing? We can look at this X years here. Yeah, it's however old the cousin is, right? Plus 5. So if the cousin is 10 years old, then, yeah, Claire is 15. If her cousin's 2, then she's 7. What about this one? If Claire is 12 years old, how old is her cousin? So now this is taking back that same thing. And now we're looking at that it equals 12. Whoops, that was a terrible 12. Equals 12. So now we have to think about the missing number, right? It's either think of the missing number, or we can think of it as 12 minus 5 gives us our x, right? Because the x plus the 5 is going to give us 12. What is it? Yeah, 7. All right, what about this next one with Diego? Let me switch up my colors here. Diego has 3 times as many comics as Han. How many comic books does Han have, or does Diego have, if Han has... Again, what's going on here? We know that whatever Han has, let me look at this right here, we're going to need what for Diego? Yeah, Diego is 3 times whatever Han has. So if he has 6, yeah, that means that Diego has 18. We just said that that would be 3N books, comic books. What about here? Diego has 27 comic books. How many comic books does Han have? Well, again, we know that that makes 27 here. What's the missing number? Yeah, you got to either think of it as 3 times something gives you 27, or 27 divided by 3 would give you your N. What is it? Yep, 9. Let's go a little more complex. And yes, I'm going to go for another color because I can. 2/5 of the vegetables in Praya's garden are tomatoes. How many tomatoes are there if Praya's garden has 20 vegetables or X vegetables? Ooh. Let's look at the variable one here. Yeah, so it's 2/5 of however many vegetables there are. So we don't know how many vegetables, so that answers this key piece right here, right? What about here if it's 20 vegetables? Yeah, because then you're just doing 2/5 times the 20, right? Should give you, what, 8? Yeah, because 5 will go into that 20. 4 times, so you have 4 times 2, it's 8. Or you could do 40 divided by 5. Either way is 8. What about here? The garden has 6 tomatoes. How many total vegetables are there? Yeah, so if we know at the end it makes 6 tomatoes, what's the missing number that you multiply that 2/5 by to get that? Well, we can also think of it as 6 divided by 2/5, right? That's still going to give us our x. Or you can also think of it as 6 times 5/2. So it gives you, what, 15 total? Because that would be 30 halves, which is 15. Let's set up this one here. So school paid $31.25 for each calculator. If they bought X calculators, how much did they pay? We don't know how much they paid, but we do know that each one is $31.25. And we have to multiply that by however many calculators. So we could figure out this last one here, right? This $500 for calculators. Yeah, because this would be $31.25 x equals 500. So we'd have to take 500 divided by $31.25. Now it would tell us how many calculators we bought. So what are the facts describing each situation that helped you write the expression? You had to look back for the word clues like older than, so that was adding or subtracting depending on how you were setting it up. 3 times as many, that meant to multiply. Here you had here you had 4 each calculator, so you had to multiply however many calculators by the $31.25. Here it had some fraction and the word of, which almost always indicates some sort of multiplication. So you had to pay attention to those word clues. Once you had your expression, you could use that to help you write the equation to actually solve the problem. So once you identified what you were solving for or how that problem was set up, then you knew what your next step had to be. So once you knew that, let's say it was the x plus 5 that we found in that first one, then all we had to do was plug in either the number here, or in that one case, we knew what the total was, or age, and then we could figure out what was the missing one. And the quantities on each side of the expression, it just depended on what we had. Like this example here, we had the 12 for the end part. That helped us figure out what the beginning was. For a lot of the other ones, we had the other piece. As far as your strategies and checking your solution, it really just depends on what strategies works best for you. Everybody's got different tools that work best for them. Usually doing the opposite operation to make sure that you've got the correct answer, it works well. Estimation can also help to verify your answer. But you need to have some sort of verification to find your answer on each one. All right, we are good to go. Hey, thanks for watching. Enjoy the rest of your day.